So in question 8, we're asked to convert 11 Skittles per day into Skittles per second. And if you think about it a little bit, you can realize, wait a minute, that's not any Skittles at all. It's right, a small part of one. So we're also asked here to write our answer in scientific notation. So, and we're also asked to show our work using ones. So I'm going to take a look at this and begin with 11, and I'll just write my units here, Skittles per 1 day. And if I want the units for my time to be per second, I've got to get rid of the days. So what I'm going to do is I'm going to multiply it by a 1, in which I've got a day in the numerator, and I'm going to go to hours next. So I'll write 24 hours in my denominator. So this is true, right? 1 day is equal to 24 hours. So the point of all of this is that this is the number 1. A day is the same thing as 24 hours. So I'm not changing the quantity at all. All I'm doing is I'm manipulating the units. And if you look at it, here's the thing. I've now got days in the denominator here and these days here. If I rearrange it, that day over day would form a giant 1, and I would be left with just Skittles per hour at this point. We need to leave hours though, because we're trying to get Skittles per second. So I'm going to now write down that if I've got 1 hour, that's the same thing as 60 minutes. So if you look now, this is indeed 1. An hour is 60 minutes. So because this is 1, I'm not changing the quantity. I'm just changing the units. And then take a look again. We've got here, I'll highlight it in green, I've got hours over hours. That forms a giant 1. So my only units left right now are Skittles per minute. So now I'm looking at Skittles per minute. I'm not concerned what the number is yet. I'll get that in a minute. I just want to take care of all the dimensions. Finally, now if I want to leave minutes and go into seconds, I need minutes to go away. So I'm putting them in the numerator. I'm going to put seconds in my denominator. And I do know that 1 minute is equivalent to 60 seconds. So again, if we take a look at this now, I've got minutes over minutes. My dimensional analysis tells me that minutes are gone as units, and that the answer to this problem is in Skittles per second, which is what we want. So now I just need to figure out what the number is. In my numerator, I just have the number 11. In my denominator, I've got 24 times 60, come back up here, times 60 times another 60, which is a fairly large denominator, right? It's 11 divided by, 86,400, which is a very small number. And I'm not going to write all the decimals down, but it's about 0.000127. So not much of a Skittle at all. In fact, can you even taste it at that point? I don't know if there's enough Skittle residue there. Now, if I take this number and write it in scientific notation, I know it needs to look like 1.27. And then again, the decimal, this is much too large, so I need to make this smaller. So I'm going to multiply it. Well, I'm actually going to divide by tens, but I'm going to do it by 1, 2, 3, 4 of them. So I can I can write it all out times. There's another 1. Divide by a 10 again. Divide by a 10 again. But at a certain point, I'm like, look, I got to do that 4 times. So it's going to be 1.27 times 10 to the negative 4th power. So this, right, is the amount of Skittles I'm eating per second. Oh, and I should write the units. It's so important. Skittles per second. Because really, without those units, this is a meaningless number. So I'm eating about 0.000127 Skittles per second.